So now let's move on with binary coded decimal or BCD. Basically, this is our 8421 code. Okay, and we could also use binary coded decimal or 8421 notation in adding binaries. But there is a problem with binary coded decimal if we're going to use it in arithmetic operation. So how many patterns do we have in decimal? We have 10. How about BCD 8421? How many combination? We have 16. So therefore, we have 6 unused pattern in BCD. So what is the effect of that unused pattern, okay, when we get the sum of the decimal in BCD? So let's check. Okay, so let's add 8 plus 5. Definitely the sum is 13. But instead of using decimal, we're going to add it using BCD code. So what is 8 in BCD using 8421 notation? We have 1, 0, 0, 0, 5, 0, 1, 0, 1. So this is our 5. Add. The result is 1, 1, 0, 1. This will be our code. But is this a legal pattern in BCD? What is the highest pattern in BCD? It's 9. It is represented by 1, 0, 0, 1. But 1, 1, 0, 1 exceeds 9. It means it should be, we should have a carry over after the fourth bit. Okay? It should be represented by 2 of 4 bits. Because we all know that 13, when we add 8 plus 5, is equivalent to 13. It means we need 8 bits to represent it. But here, it's just 4 bits. So there's an error. So this is the cause of the unused pattern, the 6 unused pattern. Okay, so how we're going to resolve it if the sum is falls on the unused pattern? Okay, so if it falls under the unused pattern, we're just going to add 6 to our pattern. Again, if it's more than 9, okay, we just add 6 to our sum so that we could correct our answer. Okay, for 1, 1, 0, 1, add 6, the result will be 0, 0, 1, 1, and then we have a carry 1 on the next higher position. So this one will be carried to the next higher position since there's no value, so 1 plus 0. So basically, the answer is 0, 0, 0, 1, 0, 0, 1, 1, which is equivalent to 13. Okay, so again, when the sum is more than 9, add 6 to force to have a carry to the next higher position. Don't forget that. Okay, let's have another example. We're going to add 2905 decimal and 1897 decimal in BCD. And we need to show the carries. Okay, so this is 2905 and this is 1897. So as you can see, I group it by 4 so that we know which number is represented by each pattern. Okay, so this is for the first position, second position, third position, and fourth position. Okay, so now let's add these first 4 patterns, first 4 values. Okay, so 1 plus 1 is 0, carry 1. So 1 plus 1 is 0, carry 1. 1 plus 1 plus 1 is 1, carry 1. 1 plus 0 is 1. Is this more than 9? Yes. So we add 6. The result will be 0, 1, 0, 0, 0, 0, 1, 0, and we have a carry on the next higher position. So add 1 plus 1, 0, carry 1. Okay, so 1 plus 0, 0 is 1, 0 plus 0, 0, 1 plus 0 is 1. And again, this is more than 9. So therefore, we add 6. The result will be, okay, 0, 0, 0, carry 1. Then add these three numbers, 1 plus 1, 0, 0, 0, plus 1, 0, 0, 1. The result will be 5 digits. Definitely, this is bigger than 9. Okay, so we exceed the 4 bits. So the fifth bit will be added to the next higher position. But before you carry the fifth position, add 6 first. Okay, don't forget that. So the result will be 1, 0, 0, 0. Now we could carry this one to the next pattern, okay, or next higher position. So add. So this will be 0, 1, 0, 0. So the final answer is 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, or 4, 8, 0, 2, which is equivalent when we get the sum of this in decimal. Okay, don't forget that. The addition plus 6 when we exceed 9 as sum. Don't forget that. If it doesn't exceed, as is the sum, we don't add 6. Okay, so now let's move on with alphanumeric code. So how we're going to represent characters using pattern. So we have different ways. We have the ASCII code. So before we use 7 bits, now we use 8 bits to represent the different characters. And aside from ASCII, we also have EBCDIC. So you're so familiar with it since you already discussed it in your CS 100 or CSS 100 or Introduction to Computer Science. So kindly review the patterns in representing characters in ASCII. Okay? And aside from ASCII, we also use Unicode. So Unicode is used to represent multiple language. Okay? So that's why we have 16-bit and 32 bits. Because we increase the number of characters represented by our pattern. Okay? So Unicode, EBCDIC, and ASCII is used to represent our characters. Now, let's move on with error detection. We want to determine when we transfer a value to the recipient, can we detect the error? And further discussion of this will be discussed in Computer Organization and Architecture and Cisco 1. So I'm just going to discuss the simply yes error detection using parity bit. So parity bit error means we're going to add a single bit to our data. And we have two types of parity bit. We have even parity bit and odd parity bit. If say even parity bit, the number of 1 should be even, while the number of 1 should be odd. So for example, this is our messages that we're going to send to the recipient. So this is even parity, odd parity. So again, we have 3 bits for our message. So +1 for our parity bit for checking if there is an error when we transfer our data. So what will be the parity bit if it's even? For this, it should be 0. Okay, so we consider 0 as even. 1, we have 1 of 1, so therefore we will need to make it even. So we have parity bit equivalent to 1. 0, 1, 0, it's odd, so we need to make it even. So that's why parity bit is 1. 0, 1, 1 is already even, so parity bit is 0. 1, 0, 0, parity bit should be 1 to make it even. 1, 0, 1 is already even, therefore parity bit is 0. 1, 1, 0, it's still it's even, parity bit is 0. 1, 1, 1, it's odd. To make it 1, parity bit is equal to 1. So that's how parity bit works. We append a single digit to our message. How about the add parity? So we make the number of 1 to add. So we have 3 zeros, so it's even. To make it odd, the parity bit should be 1. 0, 0, 1 is already odd, so parity is 0. 0, 1, 0, it's odd, so 0. 0, 1, 1 is even. To make it 1, to make it odd rather, parity bit should be 1. 1, 0, 0, it's odd, therefore parity bit is 0. 1, 0, 1, even number of ones, therefore parity bit should be 1 to make it odd. 1, 1, 0, it's even, parity bit is 1 to make it odd. And 1, 1, 1, it's already odd, parity bit is 0. Okay? Together with the message and the parity, it will be sent to the medium and it will be received. And then an algorithm will be used to check if the number of bits is correct based on the parity bit used. Okay? So that's it for this video lecture. Okay? Thank you for listening and see you on the next video lecture. Thank you for listening again.